Quick note to our listeners, we need your help. We're close to 1 million views on YouTube, and we have over 5,000 subscribers. But if we can get to 10,000 subscribers by the end of this year, that will allow us to raise money for the Finding Genius Foundation and our study to help those suffering from anxiety, depression, and PTSD. Please just take a second and subscribe to the podcast. And if you can, like the video. That'll help us get more listeners. It'll help with the YouTube algorithm. And again, help us reach our goal of 10,000 subscribers and 1 million views. We're going to hit the 1 million views, it looks like, hopefully by May of 2022. But the 10,000 subscribers will be harder. That's going to take until the end of this year. Thank you.
Do you struggle with concentration? Have you ever thought of your brain health long term? Bowmar Nutrition is revolutionizing the nootropic and cognitive health industry with Sharp Nootropic Powder and patent-pending Bright Daily Capsules, powered by NeuroBloom. If you struggle with focusing, think of Sharp as brain food that supports concentration. Sharp works with your natural brain chemistry to provide a heightened sense of well-being that can delay cognitive decline and also increase mood. Bowmar Sharp tastes amazing and comes in many different flavors, available in caffeinated and non-caffeinated versions. While Sharp is a short-term aid in cognitive health, think of Bright Daily Capsules as a way to improve overall brain health and prevent cognitive decline long-term. As we age, so does our brain. Supplementing with Bright has the potential to delay this aging process and helps your brain function optimally. Stay ahead of the curve and order yours today at bowmarnutrition.com and save $5 off with code GENIUS5.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Elodie Passeport. She's an associate professor at the University of Toronto. She's part of the Department of Environmental Engineering, and we're going to talk about her research into microplastics and contaminants. So, Elodie, thanks for coming.
Hi, thank you for inviting me.
Yeah, if you would, tell me a bit about your background and what your current research is about.
Yeah, sure. So right now I'm an associate professor, as you said, at the University of Toronto. I'm actually cross-appointed in the Department of Civil and Mineral Engineering and the Department of Chemical Engineering and Applied Chemistry. And my own educational background is in chemical engineering. And I've always been interested in the chemical engineering processes, but really applied to environmental processes. And so my work over the, since the past 10, 15 years has been on environmental remediation, broadly defined. So I study how contaminants are transported in the environment and how we can get rid of them. So I don't really look at removing them from the source, so emitting less contaminants, but really what do we do when they are there? And I tend to work on kind of nature-based solution, or what we would also call passive water treatment systems. And one easy example to picture of that is wetlands or constructed wetlands. So basically a pond with plants, and we're looking at how we can use this kind of system to get rid of the contaminants in a safe way.
What kind of contaminants and where? Like, what's an example of what you worked on?
Yeah, so we've looked at many different contaminants. I started looking from my PhD research in France. We started to look at pesticides in agricultural areas. And then later on, I looked at pharmaceuticals, personal care products, and then other types of chemicals that you can find in urban stormwater runoff, such as corrosion inhibitors, etc. Right now, for example, I'm working with tricolor, which is an antibacterial molecule incorporated in many consumer products. And it's an interesting molecule because it tends to photodegrade quite easily. So photodegrades means that the sunlight, when it hits the molecule, can induce the breaking of chemical bonds. And so we try to better understand this reaction mechanism and how we can make this happen in natural wetland systems.
What kind of chemicals and which kind of bonds are you looking into breaking?
Yeah, so triclosan is an organic molecule, so it has a few carbon atoms, two benzene rings, so two rings of carbons, and it contains three chlorine atoms. Okay, that's why it's called triclosan. Okay, you can hear the tri for three and clo for chlorine. And so when this molecule transforms into the environment, many different reaction mechanisms can occur, and some of them induce the breaking of carbon-carbon or carbon-chlorine bonds or the formation of new bonds. And so depending on the pathway that this transformation takes, you can create sometimes more toxic byproducts. And that's very, worrisome, of course, because you want to transform this molecule, but hopefully into something that's less toxic, right? You're looking at how we can do this and how you can transform this molecule without the accumulation of toxic byproducts.
Well, what kind of byproducts does it form naturally without any human intervention, and which ones are problematic?
Yeah, so 2,4-dichlorophenol, for example, is one of them. So it's a molecule that's incorporated into the US EPA list for priority contaminants, and is one of the dominant transformation product of triclosan. So when triclosan transforms naturally into the environment, for example, under the action of microbes or light, it can form this molecule. And so in our work, for example, looking at removing basically triclosan from wetlands using the action of sunlight, we try to identify which conditions of the water chemistry, which we could play with when designing this wetland, which condition would lead to the least accumulation of 2,4-dichlorophenol, so that triclosan can transform, but doesn't transform into something that would be more toxic.
Is there any way to stop triclosan from degrading? And is there any point in doing that? Is it toxic already as triclosan? Is there no point in trying to prevent it from degrading, or can you?
Yeah, that's a good question, and I can see how I would lead you to think this way. But triclosan, it's probably not the most toxic molecule in the whole world, but it is a molecule that has shown toxic effects on organisms. So it's been a molecule of concern, and it's partially regulated or regulated in different countries, for example, in Europe and in other places. So the main goal is, ideally to get rid of it or replace it with some less toxic molecule. And so it is good to want to remove it, to, in other words, to transform it, but ideally we would transform it to less toxic byproducts, so that when it transforms, it leaves behind, a less toxic mixture. And that's things like this that we've been investigating in this context.
What tends to break it down? Is it sunlight, or is there other stuff in the water that does it? Like, what's the most active things that break it down?
Yeah, so actually sunlight works really well and really fast. And triclosan is a molecule that it has a pKa. So without entering into details, it is faster to degrade and when the pH of the water is high. And so it will photodegrade very fast and very efficiently, especially when the water pH is high. And this led us to investigate if we could use algae as a way to help triclosan phototransformation. Why? Because algae, when they grow naturally in the water, in lagoon, lake, or wetlands, especially open water areas of wetlands, during the day, the algae do photosynthesis and by using the sunlight, and they take up the CO2 from the water, thus naturally increasing the pH of the water. And so we looked into this, and we also found that algae themselves are able to take up and transform triclosan themselves. So photodegradation is definitely the process that we found as the most efficient and the fastest for triclosan transformation, but other stuff in the water, the bacteria, but also the algae, as we showed, are also able to transform this molecule into less toxic products. So a lot of natural processes can help get rid of this molecule, like many others.
Well, where do these effluents come from? And could you put a section of stream that has a lot of algae in it, that it would flow through first and then release it? Would that help?
Yeah, so that's kind of this is kind of our theory, I guess. So triclosan, because it's a molecule incorporated into consumer products, you tend to find it in domestic wastewater. And so it goes through wastewater treatment plants. A portion of the triclosan is removed by the wastewater treatment plants, depending on how they're designed. But then it's in the effluent of the wastewater treatment plant, and therefore reaches, whatever lake or river where the effluents are discharged into. And so often, some wastewater treatment plants include constructed wetlands as part of a kind of third step, polishing step after all the fancier water treatment, the wastewater treatment technologies. And so in this kind of wetland polishing step, you could indeed have some open water area, which would be more like an algae pond, where algae would naturally develop, and then kind of more clear water where you might have more emergent plants, like we can imagine a wetland being. And so this indeed has the potential to remove some of the triclosan.
Is there any point in taking an effluent stream and lowering the pH substantially, allowing some things to come out of solution, and then bringing it all the way up again high to get other stuff out of solution?
I wouldn't recommend this. I'm trying to, I'm interested in looking at how we can play with environmental variables in the design and operation of this kind of systems. But I'll be very careful in doing this in the field, and I think there's a lot to be checked in the lab so that we don't create a bigger problem. What you're suggesting potentially could work, but it would have to be verified, double, triple checked before this is actually implemented.
Oh, sure. But probably the methods you're using would have to be double checked and verified as well, right? Well, what happens to a waste stream as you get to lower pH or higher pH? Like you said, it seems to preferentially break down triclosan in a better way. But are there other compounds of concern that either a very low or a very high pH would also help?
Yeah, and so every compound is different, of course. So in this case, the pH affects compounds that typically have protons that they can easily exchange. So that's the case of triclosan. At high pH, it's on its ionic form, so the proton is gone, and this is a form of the molecule that absorbs light energy more efficiently. Whereas for other molecules, it's the opposite. So for example, we've been working on benzotriazole. Benzotriazole is a corrosion inhibitor, and it's incorporating into many vehicle fluids and deicers and things like this. So we find it in urban stormwater runoff because it's found in deicer fluids, but we also found it in municipal wastewater because it's used as a corrosion inhibitor in detergent for dishwashing detergents. So we find it everywhere, and benzotriazole is the opposite of triclosan. It tends to photodegrade faster at lower pH. And so for molecules like this, there's not one solution for everything. You really have to think about what is the actual chemical cocktail that I have in a given contaminated effluent, and what's the best condition for this given chemical cocktail that I want to play with.
And do you deal with microplastics in effluents, or do you deal with like flocculants or removing, large turbidity-causing type of compounds?
Do you struggle with concentration? Have you ever thought of your brain health long-term? Bowmar Nutrition is revolutionizing the nootropic and cognitive health industry with sharp nootropic powder and patent-pending bright daily capsules, powered by NeuroBloom. If you struggle with focusing, think of Sharp as brain food that supports concentration. Sharp works with your natural brain chemistry to provide a heightened sense of well-being that can delay cognitive decline and also increase mood. Bowmar Sharp tastes amazing and comes in many different flavors, available in caffeinated and non-caffeinated versions. While Sharp is a short-term aid in cognitive health, think of Bright Daily Capsules as a way to improve overall brain health and prevent cognitive decline long-term. As we age, so does our brain. Supplementing with Bright has the potential to delay this aging process and helps your brain function optimally. Stay ahead of the curve and order yours today at bowmarnutrition.com and save $5 off with code GENIUS5.
Yeah, so our work on microplastics is really in the context of urban stormwater runoff. So we started to work on microplastics about 4 years ago, and it started from our observation that a type of urban stormwater green infrastructure called bioretention cells, which I can define in a minute, these systems, these bioretention cells, were very efficient at decreasing the pollution by suspended solids. So just to step back a minute, bioretention cells are green infrastructure, stormwater kind of control system, and they are designed by excavating the natural soil, replacing it with what we call an engineered media, which often is mainly sand, so where the water can go through very fast. And it's planted, so you have like pretty plants on it, and sometimes you have mulch, so hardwood mulch on top of the system. These bioretention cells are placed in urban environments where most of the surfaces are impermeable, and they provide an opportunity for the stormwater runoff to infiltrate. When it rains like today, and you are in a big city where all the surfaces are impermeable, here around me we only have buildings, sidewalks, roads, parking lots. So when it rains, the water just accumulates on these impermeable surfaces, which creates a risk of flooding. So now more and more cities try to implement this green infrastructure, including bioretention cell, or there can simply be stormwater ponds or green roofs or permeable pavements. And the systems are here to just provide an opportunity for the stormwater to infiltrate and accumulate less, and therefore reduce the risk of flooding. So managing the quantity of water, the peak flows of water, and the volumes of stormwater water is the main goal of this kind of green infrastructure. But research has shown that they can also improve water quality as the water infiltrates to them. And one way by which they improve water quality is by basically physical filtration of the particulates, so the suspended solid that you might have in stormwater runoff. And so they are very efficient in removing particles. And because they're very efficient at removing these suspended solids, this particle, we hypothesized that it would probably be very efficient in removing microplastics. And so that's what we studied with one of our PhD students, Kelsey Smith, and we looked at the influence and effluent of a bioretention cell that we've been studying for a few years, so we know the system very well, and we were able to demonstrate that we had more than an 80% decrease in the concentration of microplastics between the inlet and outlet of the system. Here I want to be careful when I talk about microplastic in the context of this work. We're talking about microplastics particles that are more than 100 micron in size. So between 100 micron and 5 millimeters. And I want to specify this because now we're working on the smaller size range, and it looks like the story might be similar, but definitely more complicated, because as you go down to the lower sizes, then the particles might be more able to transport into the pore of this bioretention cells engineered soil media.
So what have you observed? Have you looked at different effluents and try to characterize the size distribution and the morphology distribution of microplastics in them? Like, what's known?
Yeah, so our paper was really one of the first that showed that, first of all, bioretention cell can remove some of these microplastics in the size ranges that we looked at. Okay, and we found one of the main things that we found that was quite surprising is that there were lots of fibers in our samples. And by looking more in depth into where these fibers came from, we observed that a lot of them came from atmospheric deposition. So fibers can be transported over very long, ranges in the atmosphere, and we had a lot of fibers. The second thing that we found, and we're finding more and more now in some other samples that we have, is rubber. We found lots of different small particles that we think are rubber. It's very difficult to verify that a given particle is actually rubber. It's difficult to analyze by the techniques that exist so far, but there's very high chances that what we're observing is lots of different rubber particles. That probably comes from, car tires, and maybe in our cases from some of the pavement that we're looking at.
How does pH affect the degradation of microplastics or their continued transformation into maybe smaller pieces? What have you noticed?
So I don't know if there's any known pH effect. We definitely did not look into this in this work. And I'd like to highlight that microplastics are a range of many different stuff, right? You have fibers, fragments, film, rubber, and then you have different polymer types, polyethylene, polyvinyl chloride, polyester, etc., etc. So it's very big range of contaminants. They have different shape, which also affect their environmental fate, different colors that might affect how they are taken up by organisms, for example. They have different chemicals that were incorporated into the manufacturing process, or contaminants that absorb into the plastics that are being transported into the environment. So there are many different types, okay? Like it's very kind of complex suite of chemicals. And so they might degrade, slowly. They might degrade chemically, and maybe the pH could affect their degradation, but it will affect them in many different ways depending on what you start with. Okay, whether you start with a bead that's polyethylene or whether you start with a fiber that's polyester, you will have very different results just because they are different contaminants, simply put.
Well, it sounds like the same thing with any waste stream, any effluent. There's many different compounds, and there's turbidity, there's free-floating stuff, there's, et cetera, et cetera, et cetera. Does anyone know if microplastics are amenable to flocculation of any kind, or, in settling tanks, precipitating out? Like, what are some of the strategies used to get rid of them?
I'm not quite sure, actually, about that. Yeah, so I won't be able to help you on this.
Okay, I understand. Do you know how they interact with some of the compounds you look at, like the triclosan or any of these other compounds bind to microplastics, or kind of, stick to them and agglomerate them?
Yeah, so it sounds like they definitely can absorb. I mean, they are hydrophobic by nature, most of these plastic materials, and therefore they tend to accumulate more hydrophilic compounds, probably such as triclosan. We don't look into this specifically. It's quite difficult to do this and to do this, at environmentally relevant concentration, but many other groups have looked into this. I remember seeing a paper where they were showing that I don't think they contribute a very significant portion of the transport of organic chemicals compared to, the chemicals being transported in their dissolved phase. So I think they do contribute to the transport of these chemicals, but relatively to the overall mass of chemicals in the environment, I don't think that microplastic contributes a very significant portion.
So what are some hypotheses you're testing about remediating wastewater right now?
For microplastics, I suppose you mean?
Just in general, I'd like to go back to your specific research. What are some of the new techniques or things that you're looking at and evaluating beyond microplastics, just cleaning up effluents?
So my group really focuses on what we call this passive water treatment system. So I don't look at the more fancy technologies that are being developed in the drinking water and wastewater industry, such as, advanced oxidation processes, ozone treatment, reverse osmosis, or things like this. We don't look into this in my group. We really focus on the natural-based type of treatment systems. And so one of them is these bioretention cells. I think they have significant potential, and same as constructed wetlands, significant potential to improve water quality. But I also think that there is lots of room for improvement. In other words, as I said earlier, for example, triclosan and benzotriazole, both, like these two model or example contaminants, can both be transformed by light when they are in water. So you can imagine a pond where there is open water and the sand hits the water. They can be transformed by light. However, these two molecules require opposite condition for efficient phototransformation. So I believe that there's room for improvement, and that we can better understand the transfer and transformation processes that govern the fate of these contaminants in this kind of wetland or bioretention cell system, so that we can then better operate and design wetland and bioretention cell system to make them more efficient really at managing a given type of pollution. And that could be by having different tanks or cells in series, one dedicated to algae growth, one dedicated to wetlands, like plant uptake, things like this, for example.
So you're focusing on passive systems because they shouldn't be very expensive, and they can probably be utilized in many areas without a lot of infrastructure requirements, right?
Absolutely, and they've shown great potential, and they've been used for decades. For example, in oil and gas industry, mining industry, chemical effluent industry, agricultural areas. I mean, they can do quite a good job, and the main thing that you need is room, right? Room for a big wetland. And then you need sun, and it uses this natural energy of the sun and the microbes growing in the system and the plants growing in this bioretention cells or wetland system. So it is more cost efficient, or at least that's one of the goals, to make them, that's more cost efficient system.
What about using like cyclones or settling tanks or things like that in addition to sand filters? Is that considered passive, and is that useful?
It's not the passive that I work on. Passive would mean that you don't really need external energy, such as, electricity to power a pump. So, but the sand filter, this passive water treatment system, they can be designed in many, many different ways. A wetland actually has constructed wetlands have many different designs, and some of them is basically a gravel bed that's planted, and you can have the water coming from the bottom and going up, or pouring from the top down to the bottom. So there are many different ways to operate the system, and by engineering them a little bit, so sometimes you do need some energy to make the water flow the way you want, but you can really improve their efficiency. And this has been shown to be very efficient often in small-scale municipal wastewater treatment, where they just treat their own wastewater just with this type of engineered wetland system, and it works pretty well.
Well, what does it look like? How is it passive, and how does the geometry make it more efficient?
Yeah, I mean, often you have several tanks or several cells in series. You do have often systems in parallel, so that if one is, out of order, or you want the plants to return to a healthier vegetation status, then you can let the system rest and then use the other parallel line. So that's kind of a classic strategy. Sometimes you do have pumps, to make the water flow the way you want. I've seen system, in small or like 1,000 people type cities, where they use this upflow wetland, so the water comes from the bottom and then come back to the top, and then it returns. It kind of flows back like a little fontaine. Yeah, it works well. Sometimes you have birds coming in. It can be quite attractive.
Well, very good. What's the best way for people to learn more about your work and to see examples of it? Where can they go?
They can check my website for sure, and look at our research papers.
Okay. Well, very good. Well, Elodie, thank you so much for coming on the call. I appreciate it.
Yeah, thanks for the invitation.
Do you struggle with concentration? Have you ever thought of your brain health long term? Bowmar Nutrition is revolutionizing the nootropic and cognitive health industry with sharp nootropic powder and patent-pending bright daily capsules, powered by NeuroBloom. If you struggle with focusing, think of Sharp as brain food that supports concentration. Sharp works with your natural brain chemistry to provide a heightened sense of well-being that can delay cognitive decline and also increase mood. Bowmar Sharp tastes amazing and comes in many different flavors, available in caffeinated and non-caffeinated versions. While Sharp is a short-term aid in cognitive health, think of Bright Daily Capsules as a way to improve overall brain health and prevent cognitive decline long-term. As we age, so does our brain. Supplementing with Bright has the potential to delay this aging process and helps your brain function optimally. Stay ahead of the curve and order yours today at bowmarnutrition.com and save $5 off with code GENIUS5.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.